Welcome to Steps to Regression. Number 1, identify your independent and dependent variables. Your independent variable, x, is going to occur regardless of what happens with y, whereas y is dependent upon what's happening with x to determine what's going to happen to it. So x is going to be affecting y does not necessarily affect x. Step number 2, plot the data using a scatter plot and then add trend line. This is done for two reasons. One, by plotting the data, you get an idea of how good your relationship or your regression line is actually going to be, and preferably gives you an idea of what type of relationship or type of regression you're going to be using. For example, instead of a linear, you could be using a polynomial, an exponential, or any number of regressions. By adding the trend line, you add a check upon yourself, because it'll give you the equation and your r squared. So as you go through the analysis, you have something to check up on and to make sure you're doing it correctly. Step number 3, evaluate your r and your r squared and adjusted r squared. The r value is called the correlation of coefficient, and it ranges between -1 to 0 and 0 to 1. And what it's going to tell you is the strength of a relationship of your equation. So if it's -1, it has a negative or inverse relationship, meaning it's going to be downward sloping, very similar to a demand curve. A positive R correlation of coefficient is going to have a direct relationship similar to a supply curve. And the closer it is to 0 on either end, very low relationship. The r squared, or coefficient of determination, ranges between 0 and 1. And where we get that information from is you take your correlation of coefficient, or your r value, and then square it. So even if it's negative, by squaring it, it becomes positive. And this is going to explain the percentage of y as explained by x. So the closer to 1, 100% of y is explained by x. Closer to 0, 0 is explained by x, and everything in between. The adjusted r squared, while not used in linear regressions, is used for multiple regressions. So it's interesting to note why we use that. And the difference between the adjusted r and the r squared, or the adjusted r squared and the r squared, is the adjusted r squared takes into account that you have multiple x's and is reduces the r squared based on that information. All right, step number 4, evaluate t-tests. How good are the variables? And the nice thing about this particular test is the hypothesis doesn't change. Unlike our t-test and z-test before, the null and the alternative do not change. And basically what you're saying is the beta is equal to 0 for your null, and your alternative is the beta is not equal to 0. Or in other words, there is no relationship that exists between x and y for your null, and there is a relationship between x and y. So you want to reject the null hypothesis. You want low p-values. You want high t-values to reject the null hypothesis. Step number 5, create a formula and evaluate. The formula is based on this idea of the y hat is equal to the alpha plus the beta times x. The x is your independent variable times some sort of slope as created by the regression plus an intercept term. The y hat is the prediction of y based on this model. And understand, it is not going to be exactly like your y data. Your y data is the actual data. The y hat is the y values created based off this equation. So a slight but important difference there. So just to recap, y hat is the prediction for y based on the equation, alpha is your intercept, and beta is your slope associated with an x. Okay, so let's get started and get into some graphs. So let's take a look on the 3 graphs tab. And what you see here is I've laid out 3 different graphs, 1x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 3 different y's. And what I'm going to do here is demonstrate how the equations look, how the different r values look with different data. So I'm going to pick the first two, x and y1. I'm going to insert a scatter plot. And I'm just going to pick that one right there. Okay. Now, I can click within the chart any one of these lines and right mouse click, and it gives you a nice little window here, add trend line. So the steps there were simply highlight any of the data points, add trend line. And I'm going to pick linear because it does look pretty linear to me. The line fits pretty good. Now I'm going to display the equation on the chart as well as the r squared. And I'm going to move this over here. So let's take a closer look here. So we have, based on the data, a slope of about 2.5 for our x and an intercept of 9.4. Our r squared is quite high. So that means 80% of the data is explained by x. So 80% or 84% of y is explained by x. So I'd say that's a pretty good regression. Only about 16% of the information or the variation is not explained by x. So this is a good relationship and a good regression. You can also see that it's positive. The slope is telling you that as well, and if we ran it fully, you would see that the r value is negative, or excuse me, positive. Okay. So let's take a look at a second set of data. So I'm going to highlight x, and while pressing the control button, I'm going to highlight column y2. Again, I'm going to insert a scatter plot. And very similar to what we have before, except now it's downward trending. So we're going to expect that our slope is going to be negative as well. So I'm going to insert or right mouse click on any one of the buttons or the points there, add trend line, linear, display equation on chart, display r squared value, push close, move it over here so we can see it. And looks like, yep, negative 1.5. X for our slope, the 26 for our intercept, so it's going to cross the x-axis over here, and then a r squared of 0.84. Again, highly correlated, nice good regression, everything looks really good. Alright, and let's take a look at y3. Again, highlighting my x, with the control button down, highlighting y3. Going to my insert, my scatter plot. Now this one is a lot more chaotic than the ones before. What we're going to expect to see is a much lower r squared value than before. So clicking any one of the points, adding trend line, linear, display equation r squared, close, and let's expand that out a little bit. And as you can see, our r squared is a dismal 0.029 or 0.03. In other words, only about 3% of y is explained by x, and not a very good equation. The data is all over the place as compared to the other examples where they were much tighter. And that's why we chart them right off the bat, is we can say, okay, well, is this really going to be worth a lot of the effort that we're going to be putting into from a perspective of conducting a regression analysis? The next video, we'll be looking at the regression and going through all the steps, including the evaluation and running of the test.